Hi there. So for this topic, we're going to look at parallel and perpendicular lines. Often this question is given as a multiple choice on the CST exam, and often we're also asked to compare two different lines and question what their relative position is in space. These questions look like the following question on the screen, where it asks us to consider two lines in the Cartesian plane. They tell us that the equation of line L1 is y equals 2/3 x plus 1. And the equation of line 2 is 2x minus 3y plus 15 equals 0. Then the multiple choice question offers four options for the relative position of lines L1 and L2. That they're perpendicular, that they're parallel and distinct, they're parallel and coincident, and that they intersect but they're not perpendicular. Just to go through the concept a little bit, our parallel lines are two lines in space that look like railroad tracks if they're distinct, and they never touch, but they have the same slope. So we're talking about parallel lines. Now these ones are called distinct lines because they're not on top of each other. But if I were to have a parallel line, and then I were to come along and put another line straight on top of that line, where there's two lines on top, they have the same slope and the same y-intercept. If we're talking about perpendicular lines in space, they also have a special relationship. And perpendicular lines in space, let's say we have one line kind of going in the same one as our other picture. The other line has to intersect that line at a right angle. So, just like an intersection in space. And these ones have what are called negative reciprocal slopes. What does that even mean? I'll tell you. What it means for our equation of y equals ax plus b is that we're looking at the coefficient, letter a, that belongs to the equation in relation to slope. So that's our slope. When we talk about b, including its sign, we're talking about the y-intercept. So if two lines have the exact same slope, they're definitely parallel. They can be having the same slope and they're two separate lines, so we would say that these ones are distinct. And two lines that are on top of one another still have the same slope, but they're coincident. And I always think about the word coincidence. Oh, it's a coincidence we're both at the same coffee shop at the same time. Well, it's to be in the same time, in the same place. And that's the same thing with these lines, that they're in the same place and they're on top of each other precisely. So there's that. Oh, I've forgotten the T down here. There we go. When we're talking about perpendicular lines, they have negative reciprocal slopes. And what that means is whatever the slope is for one of the lines, the other one you have to flip and change the sign. So I'm going to call this flip and change the sign. It's the easiest way to remember it. So let's say the slope of line 1 here, just as an example, let's say the slope of line 1, so I'll say the A for line 1 was 2/5. The slope for line 2 you'd flip it, so become 5/2, and you change the sign and make it negative because 2/5 was positive. So that would be their relative slopes for this two imaginary lines. Now if we take into consideration the question that's given to us, they're asking about the relative position of those two lines. Well, I notice only the first equation is given in y equals ax plus b form, but that's really handy because we can see its slope right away. And it has a slope of 2 over 3. What we don't know is the slope of the second equation right here, because we don't know what it's not in y equals ax plus b form, and we don't know its slope. So what we have to do is rearrange that equation and then have a look. So I'm going to do this over here on the right. 2x minus 3y plus 15 equals 0. So our goal, don't forget, is that our equation has to be in y equals ax plus b form. And therefore we have to have the y on the left side of the equation and our ax plus b on the right side of the equation in the end. Now what I notice here is that we have everything on the left. And so what I'm going to do to make it easiest is I'm going to leave the negative 3y over here on the left, and I'm going to move everything else over by doing its opposite operation. So if we have a positive 2x on this side, I'm going to subtract 2x off both sides and move it right over. And by doing that, I'm going to just draw a little line here. It cancels out here. I've got negative 3y plus 15 equals negative 2x. Well, again, we don't want that 15 on the left side of the equation, so I'm going to subtract it off and move it to the other side. Now here's where a big mistake often happens, and I have students trying to combine the 2x and the negative 15. You can't combine them because negative 15 doesn't have an x stuck to it. So they're two distinct elements of the equation. So you have to keep the negative 2 that's bound to x separate from the negative 15. What I'm going to do next is I'm going to divide negative 3 from the y, and what you do to one side of the equation you have to do to the other side of the equation. If you're going to divide it on one side, you have to divide on the other. Now why did I write it out twice here? Well, don't forget, like adding and subtracting is like a big wall in algebra, and what you don't want is to have that equation only dividing the negative 3 from either the 2x or from the 15. We want to divide it out of all of our elements. So what we end up with is negative 2 over negative 3, which a negative over a negative is a positive, so it becomes 2 over 3. And negative 15 divided by negative 3 is positive 5. So our new equation for line 2, this is L2, becomes 2/3 x plus 5. Well, let's go back and have a look at our original equation that we're comparing it to, line 1. I'll write it right here. Y equals 2/3 x plus 1. What do we notice about these two? What we notice about these two equations is that they both have identical slopes. If we go back to our notes here, do they have identical slopes and the same y-intercept? Well, no, they have two different y-intercepts. So they're not parallel and coincident, but they are parallel and distinct. And if we were to go to our multiple choice answer, we can see that our answer for this question would be B. And that's how you solve a multiple choice question involving parallel and perpendicular lines.